Hello, everybody. I'm here with a problem which is related to kinetics of particles and related to anti-coordinate system because of the nature of the problem, which is curvilinear motion. As you could see here in the picture, you have a car that is traveling along a parabolic path, right? The mass of the car is given to be zero point 0.8 mega grams. That means zero point 0.8 times 10 to the 6 grams, but we know 1,000 grams is 1 kilogram. So this actually, when you convert it to kilograms, and that's the way you want to have it actually, it would be 800 kilograms. It says it travels over the hill having a shape of a parabola. If the driver maintains a constant speed of 9 meters per second, so velocity is 9 meters per second and is constant. What does that mean then in curvilinear motion, since a sub t, which is the tangential acceleration, is rate of change of the speed, therefore there is no tangential acceleration at any given instant. But that doesn't mean the acceleration is zero. Acceleration would be the centripetal or normal acceleration. So what do we want to do here? Determine both the resultant normal force and the resultant frictional force that the wheel of the car exerts on the road at the instant it reaches point A. So we want to do this at point A, right here, where the car reaches this position. So if I just show you what the axes are going to be here, you see this is the tangential axis, this is tangent to the path, right? And perpendicular to that would be the normal axis, right? And then we can draw a free body diagram at this instant and see what forces we have acting here. So the weight obviously would be mg, so that's 800 times 9.81. I believe that's 7,848 newtons, right? So I'll just put the weight here, right? So that would be, I'll just call it W. How about that? All right, then what other force is acting on this guy? Well, you got a normal force, right? Which would be perpendicular to the surface at point A. And you have a frictional force, which is opposing the direction of motion. We can call this F sub R or F sub F, whatever you want to call it, right? So basically that's the free body diagram and nothing else. So now, clearly we have to, we already know our tangential acceleration is zero, which is good news. And we have a normal acceleration, right? So remember, in general, if this is the path, right, and this is point A, remember, this would be the tangential axis, right, as I just drew it a minute ago for you. And this would be the normal axis. So there's a tangential component of acceleration in general, in our case, is zero, and there's a normal acceleration. Normal acceleration, as you know, is v squared over rho. We know what the velocity is, but you don't know what the radius of curvature is. But since we have the equation of the path, we should be able to use this formula. You guys have seen this equation before. It is a mathematical way of finding the radius of curvature. And this has to be actually calculated or you plug in the x value, in our case, 80 meters. So because different point you have different radius of curvature. So specifically, we wanted it at point A, which is 80 meters from the reference. So let's go ahead and find, let me rewrite the equation here. Y equal, let's see, 20 times 1 minus, let me actually move my picture a little bit up here. 1 minus x squared divided by 6,400, right? So if you go ahead and take the derivative of this, right? First derivative with respect to x would be about 20 times minus x divided by 3,200. And then second derivative would be just minus 20 over 3,200, right? Well, let me tell you what these are exactly are. So the first one becomes actually minus 0.001 0.0625 if you simplify it, and this one just becomes 0.00625. Now, if you plug in x equal 80 in this, right, because you want to evaluate this at x equal 80, this guy happens to be 0.362, the first derivative. So now let's go ahead and plug into the equation, right? So 1 plus 0.362, remember you square it, raise it to power 3/2, divided by absolute value of 0.00625. By the way, the reason you have absolute value because rho represents a distance, and sometimes the second derivative is negative. So to avoid getting a negative rho, you do that. So the radius of curvature is about 223.61 meters. And then you can go ahead and find the normal acceleration, which is v squared over rho, which is 9 squared divided by this. So you have a very small normal acceleration, or the car has a very small normal acceleration, which is about 0.362. Hold on a second. I guess I didn't do this right. I mixed up my numbers here. Let's see. This is actually 0.5, guys. I think I was looking at the wrong number. So let's fix this. So if you actually calculate the y prime at x equal 80 becomes negative 0.5, but negative 0.5 squared becomes actually positive, so it doesn't matter. And actually this number is correct because I did have the number correctly here. Okay, so this has units of, by the way, this normal acceleration, meters per second squared. All right, let me go back up and redraw this picture for you down here. So let's take a look at this again one more time, guys. So remember now, this is the car at this instant, right? This is the tangential axis, right? This is the normal axis. What forces did we have? We had the weight of the object, which was 7,000, what was it, 848, right? And we had the normal force and the frictional force. So basically, I'm just redrawing what we had up there. And this is point A, right? We're looking at point A. So remember, guys, we already determined the normal acceleration, which is pointing toward the center of curvature, somewhere here. All right, so now we just have to sum our forces in the normal and tangential direction and try to calculate these two unknowns. The only problem is that we don't know what this angle is. We need this angle actually, guys. Theta. And let's go back to the picture here. How would you find this angle? Remember, first derivative, which we have already calculated and we have evaluated at x equal 80, is tangent of the angle. By the way, what is derivative anyways? Derivative is the slope of tangent line. So actually y prime is tangent theta. So if y prime is negative 0.5 and that's tangent theta, if you take inverse of, remember we already calculated derivative here, right? It's negative 0.5, right? So that gives you an angle of, obviously that just means it's a negative slope, but that angle happens to be about 26.57. This picture doesn't look too good. This looks much larger than 26.57, but that's all right. So now remember that this angle then would be also theta, the same angle, right? Because this would be 90 minus theta, and that would be again theta. So based on that, if you now look at the your free body diagram and some forces in the tangential direction and set that equal to MAT, and this is your positive tangential direction. So what do we have in the tangential direction? We have our friction force, which is going in the negative direction of T. And then how much of the weight falls along the tangential axis? It would be easier if I drop the weight down here. And you see the tangential component of the weight happens to be the weight times sine of the angle. You see, it would be this component going in the positive direction, and that's the opposite to theta, right? So this would be 7,848, which is the weight times sine of this angle, 26.57. Guess what? On the right-hand side, we have 800 kilogram, but tangential acceleration is 0 because there wasn't any, velocity was constant. So look, I can easily solve for friction force, which comes out to be about, I believe, 3,510 newtons. And then similarly, be more careful in the n direction, guys. In the n direction, I know what happened to here. In the n direction, normal direction equal mass times normal acceleration. This is our positive normal, which is the direction of that acceleration that we calculated earlier. And if you sum forces in the normal, you have n, right? This n. And then obviously you would have in the negative direction. Actually, you know what? This is our positive direction. So this would be minus n because n is pointing in the negative direction of the normal axis. And then how much of the weight falls on the normal axis? A positive weight. Obviously, since we use sine for tangential direction, we have to use cosine. But equal to 800, right, times normal acceleration. Remember, we calculated normal acceleration here using v squared over rho. So 0.362, guys. So if you go ahead and solve for normal normal force, remember, these are the resultant normal force and resultant frictional force coming from acting on the tires. About 6,730 newtons. So just an example showing you that you could calculate actually the radius of curvature if you happen to know the equation of the motion, in this case, the parabola that you see here, right? And the fact that the angle that we needed for our calculation comes from the derivative, first derivative, right? Right here, right? Which we got at x equal 80 at that particular location. Okay. As always, thanks for watching and listening.